Students, yesterday I discussed different four ways of determination of concentration. Let us recap them. What is the first way? First way of measurement of concentration? Yes, it is a molarity. And what is the second one? Yes, Amisha, normality. Shruti, Rupashri, Muskan, right. Third one, molality. Yes, Amisha, Shruti, Rupashri, Swapnali, right. Swapnali, yes, yet you're answering normality. Molality, yes. Ganesh, right. And fourth one, yes, mole fraction. And in that the mole fraction, the additional portion was pph means percentage, ppt means parts per thousand, ppm means parts per million, ppb means parts per billion. So interconversion among them should be what the clear to you. Now we are what correlating the different concentrations. In front of you, I present the different ways of the finding the concentrations. See here, different units of concentration. The first one is relative. That I said no, percentage, ppm. These are relative terms. So mass percentage. Percentage also is of two types. I hope you are getting this cursor. The first one is mass percentage, weight by weight. So weight of the one entity divided by the total weight that we are what the considering to find out the percentage. But what is the intention to find this percentage? To find the ratio of the weights. Here volume percentage. Here we consider ratio of the volumes. These are relative terms. Other one, percent mass by volume, means this in case if we are expressing that, then W by V. So these are the three ways of the determination of relative concentrations. But if we are representing by mass by volume, then specifically to be mentioned that it is W by V. Everywhere actually it should be, but conventionally, depending upon the chemicals, we do what the follow that. Because if we take a sugar and the water, then sugar will measure in terms of the gram, means my mass, and the water by means of the volume. So it will be the mass by volume, W by V. So W by W, V by V, and W by V. These are the three ways of determination of relative concentrations. Volume-based concentrations, which are molarity, that we have discussed, represented by capital M, normality, capital N, formality, capital F, that we have not discussed. But just understand it again related to the similar concept. That's a volume concept. Now question you will be with molality. That term we have discussed. Why it is not there? Because here see the heading is volume basis. Molality is a mass basis. Mole fraction here they are considering as a mass basis, means the weight basis. So on volume basis, molarity, normality, formality, and mass basis, molality and the mole fraction, or only the first four you can understand. And the mass as well as volume basis, parts per million, parts per billion, means it depends what is the chemical, what is the solute. If solute is liquid, then solution when we prepare, then it will be the volume by volume. It doesn't mean if it is liquid, the mass cannot be determined. Means it's a way of presentation. Here mixing may what the possibility are considered. It's a parts per million and parts per billion. It's a summary of the different ways of representation of concentration. From this, what should be clear? The headings are there, no? And different ways of representation of concentration should be clear. I repeat. Relative concentrations are represented in terms of percentage or parts per 100 or parts per million, but represented is considered as what the percentage. That can be represented in terms of weight by weight, volume by volume, or weight by volume. Therefore, they have considered mass as well as volume. ppm, ppb, pph, ppt, all things will come, but representative concentrations are written here. And on a volume basis, normality and the molarity and additional formality you can consider. And on mass basis, molality and mole fraction. So four different ways. Actually relative, this relative is applicable for all in general. And all these weight by weight, volume by volume, and the weight by volume is applicable for the mass as a volume basis. Mass versus the volume basis, M by V, or the W by V. In that category, but in true sense, all things can be applied here for ppm and ppb. So main thing is this volume basis and what the mass basis. So students, is it clear to you now the different ways of representation of units of concentration? You will talk now because I am presenting. At that time I don't know what you are chatting or what you are mentioning in the chat.
Yes, sir.
I could not hear you.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Yes.
Sir.
Now I move to
Yes,
the
sir.
next point. Let us see how far you can digest the things. Yes, I hope it is readable now. These are what the formulae that I discussed yesterday: molarity, normality, molality, and mole fraction. And it was expected that we should write the notes of that. That is a homework of the yesterday's lecture. Here's the mole fraction, that N1 or N2, these are the number of moles. So we are talking about the second compound, so N2 upon N1 plus N2, they have considered. And then the ppm, ppb, or relationship between them. ppm means 1 milligram per liter, ppb means 1 microgram per liter or dm cube, and 1 ppm means 1000 ppb. I ask you the question, can you understand why we say 1 milligram per liter means 1 ppm? Or I have to explain? Yes, you have to talk. Is my question clear?
Yes, sir. Understood, sir.
Okay,
Yes, sir.
Cooper understood. Yes.
Yes, sir.
Other students understood thing why 1 milligram per dm cube means 1 ppm. If any other problem is there, say no, then I will discuss. Otherwise, I'm moving next. Yes, I at least say yes or no something because only one or two replies I found.
Understood, sir.
Okay, third reply I found. Okay, can anybody explain? Those three students have said, can they explain what they understood? Or any other buddy who understood thing can explain. Yes, Kuperkar, Alia, I think Alia has answered. And further, one more student was there, I don't know the name. Yes, anybody can explain. Language has no barrier. Okay, if no, then say no. Those who said no, yes, they understood, they say no. Because I understand. Understanding is the one thing and explanation is the other thing. For expression, for exploring, to explain, some additional studies what necessary. I understand that. I am not saying that if you could not explain means you are not understood. But you say answer quickly so that I can move next. Yes, Kuperkar, can you answer?
Yes, sir.
Yes, explain.
Sir, 1 milligram is the 1000 part of 1000.
1000 part of gram. Okay, right. Next what? So why ppm? Million is there. No, million means 10 raised to 6. I'm not understanding why 10 raised to 6 is there, and your explanation is regarding thousandth part only. Kuperkar, are you understanding my question?
Yes, sir.
1000 part, okay, I understand, but 1000 and million, where is the relation? Yes, any other buddy who can explain?
No, sir.
No.
No, sir.
So what do you think? Shall I explain or you will study on that?
Sir, shortly explain.
Okay. See, dm cube means liter and milliliter. Relationship between ml and liter is 1000. Means 1 liter is equal to 1000 ml, or ml is a thousandth part, or cm cube is a thousandth part of dm cube. At least you know that much.
Yes, sir.
Okay. Now volume and weight, somewhere we have to correlate. If we consider water has density 1 roughly. So water 1 ml or 1 cm cube water means what's the weight? 1 cm cube water means what's the weight? 1 liter water, what's the weight? Density is 1. Density means mass upon volume. If volume is 1 liter or 1 dm cube, then what should be the weight? It's 1 liter water.
1000 gram.
Yes, 1000 grams, 1 kg for 1 liter, 1 kg. 1 and 1 will get cancelled, but density is what? 1 for water. If I take 1 cubic centimeter, then how much weight will be there?
1
gram, absolutely. So is it clear? 1 cubic centimeter of water means 1 gram.
Yes, sir.
Okay.
Yes, sir.
Now, previous my logic was 1 liter is equal to 1000 cubic centimeter. 1000 cubic centimeters. Cubic centimeter means gram, only gram. But now what I am doing, I am dividing that gram 1000 times. I am dividing gram 1000 times. So what will be the answer? Division of gram to 1000 times, that part is called liter. Divide 1000 times, it is called milliliter. Then gram divided by 1000 times, it is called
Milligram.
right. Milligram. See, now in reverse way I am going now. I am taking 1 milligram, which is thousandth part of 1 gram, and this 1 gram is a thousandth part of, yes, help me, 1 gram is a thousandth part of which one? 1 gram is a thousandth part of what? 1 milligram, thousandth part of gram. 1 gram is a thousandth part of,
1 kg.
right? 1 kg, 1 kg. And that 1 kg means what? In case of volume, liter. Liter means what? dm cube. So, logic. 1 milligram is a thousand part of 1 gram. 1 gram is a thousand part of 1 kg or 1 dm cube. So, if totality, if you see, this 1 milligram is a thousand into thousand, it is a 10 raised to 6, 10 lakh, 1 millionth part of dm cube. So 1 mg is a 1 millionth part of kg. Kg in terms of volume we are measuring, therefore dm cube. So 1 millionth part, parts per million. So 1 part per million. Therefore 1 ppm is equal to 1 milligram per dm cube. So I could explain you 10 raised to 6 how it came. Million means 10 raised to 6. 10 raised to 6 came because of thousand. 1000 came because of conversion of milligram to gram. Other 1000 came because of conversion of gram to or the kilogram or the dm cube. Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes, if no, then say no, because only few responses I am finding, and those also are feeble responses, not loud responses. Rishikesh, is it clear?
Yes, sir.
Okay. Now see, second is ppb. pp means parts per billion. So I want here 10 raised to 9th part. Up to 1 milligram, it was 10 into 6th part. Further divide this milligram by 1000 times. Divide milligram 1000 times, you will get microgram. Therefore, 1 microgram per liter means it is a billionth part of that liter or dm cube. Micro means 10 raised to minus 6. You might have heard that minus 6 came. Why? 10 raised to minus 3 divided by 1000 means 10 raised to minus 6. So 10 raised to minus 6 for gram. And gram is a thousand part of that kilogram. Therefore 10 to minus 6 into 10 to minus 3. So total 10 to minus 9. So therefore it is represented ppb. And if relationship among them, if you see here, milligram and microgram, answer for my question, who is larger? Milligram is larger or microgram is larger? Milligram quantity is large or microgram quantity large? Right, milligram is a large, so ppm is larger. So 1 ppm is equal to 1000 ppb. Milligram, microgram, 1000 number is there between. 10 to minus 3 is a 10 to minus 6. So ppb is the smallest unit. Smallest means among these here, ppm and ppb. So 1 ppm is equal to 1000 ppb. So it's the relationship between ppm, ppb, and the understanding of the ppm and the ppb. I hope it is clear to you now.
Yes, sir.
Yes,
Is it
sir.
clear?
Yes, sir.
Okay.
Yes,
Now,
sir.
important part of the syllabus. Interconversion of concentration units. Relationship between mole fraction X and molality M is represented here. What is a mole fraction? So mole fraction for solute, that's X solute. Mole fraction for solvent, X solvent, into 1000 divided by M solvent. That M solvent is the molarity. Just wait. M solvent is the molar mass of the solvent. Molecular weight, you can say, or molar mass of the solvent they have considered. So you do one thing, write down this formula, and I want answer next time. How this formula came, you have to work on that. Write down this formula or take snapshot. Is it possible, or shall I give hint and then you will think? I'm not giving complete answer today because I want that you should think. Do you want some little hint I have to give, or you will work?
Give the hint.
Yeah. What about others? See, you talk. I said no. Be communicative.
We will do.
No, student. I'm not understanding the situation.
We will work.
We will do, sir.
Okay, they will work. Yeah. Okay. Okay. Good. Out of 3, the 2 are saying. And suppose if you could not, the next time also I will give the hint to you. Direct answer I'm not giving. Hint I will give to you. Okay. Good. You work. What you have to do, it is not given in the book. You have to work for this formula. Don't remember this formula directly. How it came. If you work on this, no, then understanding will be more. You miss in future when you have to work with the different concentrations as a chemicals, it will be easy for you because you are visualizing the things. Good approach that I am finding. But nevertheless, those who said the hint necessary, the work on your own and then you ask for the hint. Good approach. Then using that formula, different numericals are there. Only the substitution values are there. If mole fraction concept clear, then you can readily or easily solve such problems. Yes, numericals are there. Now, additional relationship. Relationship between molarity and molality. This also you do write down or take snapshot. And I want that you have to work to understand this formula. It is not so easy. Previous thing was there, little bit you will understand, but here little additional study you need to do, some more work you need to do. That small m means molality, capital M means molarity. Previously what they did there, they were considered molecular weight, or what the solvent, molecular mass they considered, and for molecular mass they are saying, say, m solute or solvent they are mentioning, only m they mention means it is for molarity of solution, but m solute or m solvent is mentioned, then that is what the molar mass of solute or solvent. And d solution means density of solution, say additional term came here. And this point not one, see when point not one or 1000, if such things are coming, it means it's a game of what the conversion, that's a gram to milligram or liter to ml, just that the conversion is there. Yes, will you work on this also? Is the second formula given to you?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
You work on this. Yes, I hope you have taken the snapshot or you wrote that the formula. See, it's a third relationship between molarity and normality. They are given here. Normality of solution is equal to molarity into molar mass upon equivalent mass. Molar mass means what concept? I hope clear to you. Equivalent mass. Last time I had given you examples also, different hands, person, may feel odd, but it is just for the understanding purpose, in order to cognize the chemistry. It's only intention. Don't get hurted because of that example. Okay. Other normality of acid, if you are talking molarity into basicity. Basicity, we measure basicity for acid and acidity for base. Interesting thing it is. How many OH minus with which the H plus ion combines of the acid, that's called basicity. Means that basicity is equal to number of H plus ion reacting. Means we are not saying it's acidity. With how many OH minus, that is a chemical terminology that we have to understand. So HCl is monobasic, H2SO4 is a dibasic, NaOH is monoacidic base. HCl is acid, but is a monobasic acid. H2SO4 is acid, but dibasic acid. NaOH is a base, but is a monoacidic base. Calcium hydroxide is a base, but is a dibasic base. Phosphoric acid is an acid, but a tribasic acid. Are you following what I'm saying?
Yes, sir.
Yes. And in case of the oxidizing inducing agent, that it's a game of the number of electrons. So we have to consider. So in case of acid-base chemistry, basicity and acidity concept, and in case of the oxidizing inducing agent, number of electrons transferred. That is important. And this is a general formula for the normality of the solution. It is a third relation. Take a snapshot and see whether you have understood these relationships or not. Snapshot or write down this formula. Yes, done? Yes, have you completed?
Yes, sir.
Yes, sir. Yes.
Okay.
Yes, sir.
Okay, I'm going to the next point now. The fourth relation. Relation between molarity and concentration in ppm. Molarity and ppm. Or the relation that molarity is equal to concentration in ppm into 10 to minus 3 divided by mass of solute. It is very easy to understand, but you have to work. Directly don't buy heart that. Work on that. How this formula might have come, you have to work as like I told you, ppm means 1 milligram per dm cube or 1 milligram per liter. Why milligram per liter? That I explained. In that way you have to work. Okay, once these formulas are clear, just simple substitutions will be there. Yes, is this formula clear? Clear means you have to work on this, how this formula came. And don't work blindly. Actual visualization is necessary. Take snapshot or write down this formula. Yes, completed?
Yes, sir. Yes, sir.
Yes, sir.
Okay, these four formulas are there and about which you have to work, and many problems are there. Those problems we can solve. So first you work with that, and then the problems I'm giving to you, you can work with those problems or one problem for the each category I'll discuss. If doubts are there, we will have the further additional discussion. Now here one term, percent composition of element in chemical compounds. See the formula here. Percent composition is element. See percentage of different solution different. Now here we're talking about the element as like aluminum, sulfur, chlorine, sodium, carbon. These are different elements. And what have they given? Will anybody answer? Different values are there in front of element. For example, manganese 55 they have given. What that 55 is?
Atomic
Atomic
mass.
Atomic mass. Yes, any other answer? Yes, atomic mass. Is it right or atomic weight?
Both are same.
Both are same. Oh, okay. See, actually, they are not. Means you should understand this term. At least at TY level, you should know that we are saying the weight. Just tell me, mass. The unit of mass is. Yes, help me now. Yes, what happened? Means somewhere we were talkative till now. You were talkative, but today what happened? I want to know. Yesterday, one student. I know the student. A little problem came, means he was talking. I'm not saying he's talking about my lecture, but disturbance came in the lecture. So it over, that issue is over now. I left that issue. And I will not torture. I know the student, but even though never I will say that this student is there. So there, because of that, don't get disturbed. In case if it is a situation, because I asked yesterday, who is there? It happened that mic was on and he might be talking with some other buddy, or he was talking to self, and because of that issue came. But I wanted to know, in case if such thing happened, you dare to say yes, because of me this thing happened. If you want, you apologize, otherwise leave that. But don't hide yourself. Don't restrict yourself. I got the reply, we don't know that. Okay, that student might be not knowing the thing, not knowing that person. And if anybody was knowing, should reveal. And rather than that, I was expecting the person who was there should say, okay, I was there, sir. If that person feels that sorry, then say sorry. And I'm not saying sorry, apology should necessary. If not, then so will do. But boldness is necessary. Clarity is what necessary. I expect clarity. I will never say that why you did that, say sorry. No, sorry and no, these are the only simple words. Action necessary, that action took place, now nothing we can do. So leave that, but I wanted to know who is there. Curiosity was there. Maybe it happened mistakenly, intentionally, whatever may be the reason. I wanted to know the person, therefore just I asked. I was expecting a simple, bold reply, I was there. In spite of others should tell, that person should say that I was there. It is my expectation. After all, it is my view. But after all, I just asked, and because of that, if you get disturbed, if you get frightened or fear is there, leave that, release that. Don't worry about that. Don't think in that way. It is just my appeal, just my suggestion to you. After all, it's your decision. Means what I am finding is your interactions are decreasing. It may be somewhere that you are finding terribly, you are failed, or your score is less, or your performance is poor. So you are in tension. So confidence is somewhat depressed. If such things are there, don't worry about that. Explain. Let you be wrong. Otherwise, he would have answered. Ismail, are you there? I think Ismail is not there. Otherwise, he would have answered. Whether he is right or wrong, that is not important. But innocently, sometimes, yeah. Hello?
Gram, sir.
Yes. Anybody want to say anything?
Gram unit.
No, I could not hear. Right?
Gram.
No, gram. Yes, right. Okay. Now answer to the question is coming. Unit for mass is gram or kilogram. I hope about that there is no question now. Is it clear?
Yes, sir.
Now
Yes,
screen is open. You can reply
Yes, sir.
also. Yes. Unit for weight is.
Newton.
Mass.
Yes. Loudly. Otherwise type there.
gram,
Weight. What is the meaning of weight? Gram. No. Unit for in physics, weight and mass, these two different entities are there. Scientifically, we are talking about. Yes, Poonam, Newton. Yes, Shruti, Newton. Okay, students, in between network was lost. Yes, weight means mass into.
Mass into gravity.
Weight means mass into.
Gram.
G means what? Gravity. Yes,
Gram.
right. Not gram. Here, mg. Weight is equal to mg. Mg means not milligram. Weight is equal to mass into gravitation. That's a gravitational acceleration due to gravity, or you can consider acceleration, but we are weight generally in terms of gravity we consider. So acceleration due to gravity, that's a g. So mg means weight. But it is our usual practice, Ganesh, that we say weight means gram or kilogram. Therefore, Rishikesh might have said that it is what the gram or kilogram. It is general practice. We say weight of crucible, and you say weight of crucible 17.056 gram, or sorry, yes, you say it is a gram. So you understand that it's a unit of weight. No, it is our conventional way by which we represent that weight. It is not so scientific, but here in this calculation, we are very scientific. Weight of mass is gram or kilogram. Sorry, unit of mass is gram or kilogram, and unit for weight is dyne or Newton. Now answer for my question. What are the numbers were there? For manganese 55 was there. That number was with no unit. And you were saying that is the atomic mass. And few have said atomic weight, or especially I was saying it is atomic weight. Answer for my question. What is the unit for that atomic weight? What is the unit of equivalent weight? What is the unit of molecular weight? Gram per mole. Oh, great. Other, what is the unit of atomic weight? Equivalent weight, molecular weight. While calculating the term of, explain the term mole that I
Molecular
was
weight.
saying. Yes, Rupashri, repeat please.
Molecular
Mass
weight
unit.
for mg
Yes,
per
Amisha.
mole.
Atomic mass weight. AMU.
Atomic mass weight unit is AMU. My question is atomic weight. What is the unit of atomic weight? Atomic mass unit, that's a AMU, atomic mass unit. It is there. Absolutely, Amisha is right. My question, what is the unit of atomic weight? What is the unit of equivalent weight? What is the unit of molecular weight?
Dalton.
Dalton.
Molecular weight gram per mole.
Gram per mole. No. See, molecular
Or
weight,
molecular weight.
molecular weight, Rupashri, Amisha, and others. Molecular weight, equivalent weight, atomic weight has no unit. Has no unit. We express them in terms of gram. Then we consider it as mole. That those many grams. 55 gram of manganese means 1 mole of manganese. Avogadro's number of the manganese atoms. Now question arises, how is it possible that weight has no unit? See students, when Dalton, that Amisha said that it is Dalton, at the beginning, that's a mass of the atom was measured in terms of Dalton. Afterwards, it was said as AMU, atomic mass unit. Dalton you can consider atomic mass unit. So people were considering the mass for the atom. But later on, Miss Dalton's, I think you might be knowing, no, okay, for you video I prepared last year, not last year, but pre-last year. Okay, last year, for you different syllabus. Okay, you don't know. Otherwise, you go through syllabus of FA Basic, detailed video is given about the Dalton to Boyle or Burgess to Boyle. You will find that the detailed video. Dalton, when discovered that atom at that time, people were thinking that atomic mass, that mass should be there. Dalton's era is beginning of the 18th century, and in 1860, almost after 55 to 60 years of Dalton's concept, the modern atomic concept that you can consider, a Canizero or a group of the people, they decided we are with confusion because Russian scientists are saying one thing, German scientists are saying other thing. So different variations, considerable variations were there. All the things are to brought to the solution. So therefore they suggested, because of Canizero, the Avogadro number came. Avogadro's work was in the era of Dalton only, nearby by 1911. But Avogadro's number came in 1960. Sorry, 1860. Avogadro was in 1811. Avogadro put forward his concept. It was most neglected concept. People has not cared for its concept. But in 1860, after almost 50 years of his discovery, people come to know importance of Avogadro's concept. And applying Avogadro's concept, they found Avogadro's number. And because of Avogadro's number, it becomes very easy to find the concept of what the atomic mass, somewhat, or magical atomic mass. But people later on, at the meeting only they realize, when they consider hydrogen, answer for my question, hydrogen can exist in which forms?
Gas.
Which, yes, Amisha?
Gas.
Yes, it is in gaseous form, but different isotopes of hydrogen. We say only H, but what are the different isotopes of hydrogen? It can be 1H1 usual, or it can be, yes, it can be deuterium, 1H2,
Tritium.
right? Deuterium. Similarly, carbon also can be carbon 12, carbon 13. Carbon atomic number is 6 only. But I am talking about the atomic mass or the mass number. Mass number, I don't want to word, mass number. 12 may possible, 13 may possible. For oxygen also, 16, 18, this variation in the atomic number is possible. There were the many elements, they have the isotopes. So when you are considering the weight of the atom, then weight of the 1H1 and weight of the 1H2 is considerably different. Weight of the carbon 12 and carbon 13 is different. So when you take the 1 mole of the atoms, then what is the exact weight? Exact weight we can't say 12 or 13. It depends percentage of carbon 12, depends on percentage of carbon 13. So people understood somewhere we should use the relative term. Relative term. So comparison. So it is compared. So for comparison, different ways are there. Few have considered carbon 12 as a standard. Few have considered hydrogen as a standard. Few have considered oxygen 16 as a standard. But somewhere standard was necessary. So with the help of that standard, relatively it is compared. Example, boron. Boron is 10 times heavier than that of the hydrogen. It means one boron atom is 10 times heavier than that of the hydrogen. So relatively we are considering one bunch, that's a mole of the boron and 1 mole of hydrogen, the weight between them is a relatively. So when we consider relation, for example, percentage is a relation, mole fraction is a relative term. Mole fraction has no unit because whatever the unit is there and at upside, that unit will be cancelled by what the downside. Provided these ratios are taken, means I'm not saying that ppm, ppb, their mass upon volume, different entities may possible. Here we are talking about the mass of the atom. So they were considering the ratio of the mass of the hydrogen and mass of the boron. So relatively when it is considered, then the unit get cancelled, therefore it has no unit. Now question arises, it would have considered then the in spite of weight, the mass term can be used, but the weight term is used because of weightage. Average we have to consider. If any isotopes are there, then every isotopes remains with different mass. Then the weight we are considering, average weight is a relative term that they are considering, or average term they are considering. And for that, we are using the term weight in spite of mass. But still, this weight is not the weight that generally we consider weight is equal to mass into the g, m into g. It is not like us. It is regarding the weightage that you consider. No, now unit number 1, if you are studying, then the beginning portion is the easy portion. Now the mathematical portion came. Afterwards, sampling portion came. It is for how many lectures? So what is the weightage for that? Depending on the weightage, you get inclined to study, especially during the days of the examination. Yes, students, are you following? So that weightage that we consider, weightage to this topic is 40%, 50%, see, percentage. So in terms of relative, it is said, relative to others, relative to complete, this is a weightage. So that weight, therefore the term came weight. It is not a weight term because of the usual mass and gravity relationship, that weight. So I repeat, see, if you have studied physics, you might be knowing mass unit is gram or kilogram, weight means mass into g means Newton or dyne. So in case of atom also, at the beginning people were started to measure the mass. They were very scientific and they were considering it is in terms of Dalton or AMU. Then it was expressed in terms of gram. But later on people realized the difficulties. In order to bring the avoid the problems, relative way of measurement is accepted, and that relative way is nothing but the weightage way. Relative. Therefore, it is a weight came. And then that and the problems were because of the isotopes. So on an average, in general, what remains regarding that the answers are there, regarding that the atomic weight we consider, considering the all isotopes of the element and abundance of those isotopes. Students, are you following what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So it is a very basic thing, atomic weight, but blindly we have taken. Actually, question should come from your side. Atomic weight means unit should be there, Newton or dyne. One time it's a gram, kilogram, you'll understand, but it has no unit because it's a ratio, it's a relation, fraction, as like the ratio that we find, no, in that way. Ratio always will not be in terms of fraction. If it can be higher because relative to hydrogen, boron is heavier, so it will be higher. But with respect to boron, hydrogen is what the lighter. So references are what the considered. References are considered, but boron is not considered one. Hydrogen is considered as what the one. Especially Dalton was considering hydrogen as what the 1, and with the help of that he has found, but the unit he was considering as a Dalton or what the AMU. It was a very, very important concept that I discussed with you. I hope that you understood its importance or the severeness. My point of discussion is these weights. These are the atomic weights. Those have the no units. So percent composition of that element in the compound, if you have to find, then mass of that element in 1 mole of the compound means elemental mass. Means if you consider oxygen in water, in formula H2O, 1 oxygen is there. What about hydrogen? 2 hydrogens are there. But 1 hydrogen has how much atomic weight? 1. So 2 hydrogens, 2. About oxygen, atomic weight is what? 16. So that mass you have to be considered. Into 100 divided by mass of 1 mole of the compound. For example, H2O if I consider. And if I have to talk about the hydrogen composition, then will you answer mass of element in 1 mole of hydrogen, 1 mole of water? What will be the mass? Mass in terms of, for 1 mole, certainly mass will be there. That will express in terms of gram. 1 mole means atomic weight in terms of gram or molecular weight in terms of gram. I want to know answer from you. How much hydrogen will weigh in 1 mole of water? What is the weight of hydrogen or what is the mass of hydrogen in 1 mole of water?
2 gram.
1.
1. Okay. What is 1? For hydrogen, 1 means what? 1 is a atomic weight of the hydrogen. Means 1 mole of hydrogen weighs 1 gram. Are you getting the mole concept? Atomic weight is 1. But 1 mole of hydrogen weight is 1 gram. 1 mole of aluminum weight is 27 gram. 1 mole of sulfur is 32 gram. 1 mole of chlorine is 35.5 gram. Mole and gram, they are related. And I said here 1 mole of water. So in that, how much hydrogen is there that you have to find out? Here 1 is given, hydrogen weight, 1 mole of hydrogen atoms if you take, then the weight will be 1 gram. I said water. What is the formula of water?
1,
What's the formula of water? H2O. So how many hydrogens are there?
2, 2,
2. So if I take 1 mole of H2O, 1 mole of water, compound is water here, then how many hydrogens will be there?
2, 2,
2 is a number, don't say. See here, unit is important. What 2? 2 is what? 2 kg, 2 liter. What 2?
2 gram.
2 gram. No. See why I said that. My question, listen question carefully. 1 mole of water will give how many hydrogen? How many hydrogen? 1 water molecule gives 2 hydrogen atoms. My question is 1 mole of water gives how many hydrogen atoms?
2 mole of hydrogen.
Right. 2 mole. I was expecting 2 mole as answer. 2 mole. 1 mole means 1 gram. 2 mole means 2 gram. So these terms are very important. Mole is a number. Number of that hydrogen has some weight, and that weight is 1 gram. In water, by formula double hydrogen, 2 hydrogens are there. So therefore, whatever the number of water molecules I am taking, double will be the number of hydrogen atoms. 1 mole of water, 2 moles of hydrogen. 2 moles of hydrogen means 2 gram. So here 2 gram will be there into 100 divided by mass of 1 mole of compound. Now answer my question. What is the mass of 1 mole of water? What is the mass of 1 mole of water? Oh no, somewhere problems are there, students. I'm not understanding why are you not talking. When I discuss mole concept, you are saying that it is clear. Then what is clear? Here I am asking 1 mole of water means how? What is the weight?
18, 18,
What 18?
18.
18
What
gram.
18? What is the unit of 18 or no unit?
No unit.
Okay, no unit. Any other answer? Or if you have the same answer, then say same answer. Question is 1 mole of water means what is its mass?
18,
18. Is there any unit?
no unit.
No unit. Okay. Answer for my question. What's the formula of water?
H2, H2,
H2O. What's the molecular formula for water? H2O. What's the molecular weight of water?
18.
18,
18. Molecular weight has no unit. That I said molecular weight has no unit. But when we take that unit in terms of gram, that 18 gram means 1 mole. Reverse. 1 mole is the number that I said to you, said already. 1 mole means Avogadro's number of water molecules when we will gather, then certainly it will be with the mass, no? That Avogadro's number of water molecules that we represent in terms of gram to what? Molecular weight. When molecular weight, atomic weight, equivalent weight expressed in terms of gram means mole. 1 mole quantity is there. Whatever the entity is there, that's 1 mole. 1 mole of electron, 1 mole of hydrogen, 1 mole of the oxygen, 1 mole of water. Here molecule we are considering. So 1 mole of compound, 1 mole of water. So question was, what is the mass of 1 mole of water? 1 mole means Avogadro's number. Formula of water is H2O. Molecular weight of water is 18. So 18 is molecular weight. 18 gram means 1 mole, or 1 mole means 18 gram. Are you following what I'm saying, or I'm confusing you?
Understood, sir. Understood, sir.
Yes, sir. Clear.
Student, what is the problem? Let me know. Is it clear? Yash, is it clear?
Sir, please repeat something.
Amisha, is it clear?
No, sir. Please repeat.
See, if not clear, then you have to ask me. Don't expect that if you are keeping mug, then I have to repeat. I want boldness, I want clarity. And to bring clarity, in order to have the clarity from you, in order clear-cut message from you, what shall I do? Let me know. If any problems are there, if any hurdle is there, if any fear factor is there, then be free to ask. Be free to tell. But I want clarity. Total 15 students are there and only 2 and 3 students were replying. If yes, then say yes. If no, then say no. By your replies, I will come to know. No. Okay. Alia, what's the problem? Why not answered?
Sir, network problem is there.
Yes, yeah. Yes, I couldn't hear clearly. Yeah. Network problem. Okay, but text could be done. Amisha has answered, she won't read. Ankita, what's the problem? Why I had not given any message or talking, communication? Okay, now I'm asking to you, is it possible for you to talk clearly? If yes, if it is, then say yes, you in chat box. If I'm presenting, then you talk. If not presenting, you can give the message in the chat box. Now I want answer. And if you don't want to give clear-cut responses, then I suggest don't attend this lecture. See videos, because you're remaining idle, and when you're remaining idle, I'm wasting my time. Is it clear or not? I remain with doubt. What's the problem? Why students are not answering? That question comes to my mind. Therefore, I'm asking, why are you not answering? Answer the question, why are you not answering? Or you say, you can attend lecture, you have to say, I will not talk anything. Be clear cut in that. I don't want to talk. Only I am here to listen to the lecture. Dare to say that. I will allow you to sit for lecture. And have the brevity, have the clarity. Only I am expecting clear-cut responses from you. So one by one, I am asking to everyone. Yes, Alia, is it possible henceforth onwards? Clarity.
Yes, sir.
Amisha, is it possible?
Yes, sir.
Ankita,
Yes, sir.
Ganesh,
Yes, sir.
Mayur,
Yes, sir.
Muskan,
Yes, sir.
Poonam,
Yes, sir.
Rupashri,
Yes, sir.
Rishikesh,
Yes, sir.
Shivangi,
Yes, sir.
Swapnali,
Yes, sir.
Vaishnavi,
Yes, sir.
Yash.
Yes, sir.
Okay, I hope that you will be very prompt. See, don't expect that the other answered no, the same answer or there. No, you have to answer at your own. Individually, you have to give the responses. Everyone has to give the responses, and that I expect. And I said already, if you don't know to give response, in advance you have to say, I'm sitting for lecture, but I'm not giving response. In advance you say that. Declare that. Declaration it is called. Okay, now see, listen carefully. When Dalton has brought his Dalton's atomic theory, at that time, he was fascinated by the concept of the atom. An atom means certainly the atom has a mass. So atomic mass concept was there. So atomic mass can be represented in terms of AMU or Dalton. That concept was there. But in order to have the uniformity, Dalton's era was by the beginning of the 18th century to bring uniformity after the half of the 18th century. But by 1860, when all scientists gathered together, they decided one thing. And there they understood the importance of Avogadro's number. Avogadro's number of atoms, when they are gathering together, when they come together, then their mass is atomic mass. So their Avogadro's number has got the importance. And that Avogadro's number means mole. 6.022 into 10 raised to 23. So mole is a just number. I told you frequently. Up to here, are you following what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Then problems were
Sir.
there. That's a mass. Mass means it is represented in terms of gram. Because of the isotopes, hydrogen 1 and hydrogen 2. Hydrogen 1 has one mass, hydrogen 2 has other mass in the same hydrogen gas, different. So practicality and ideality, those were not matching properly. So that is to bring to the proper level, proper consciousness should be there. So average values were what they considered, proper percentage were considered. Experimentally, those two are the determined. And for that purpose, relativity was considered. relativity. So they were considering pure carbon 12, only and only carbon 12. And with carbon 12, they were comparing other. So with reference to carbon 12, you are comparing the weight of the oxygen. With reference to carbon 12, you are comparing the weight of the manganese or mass of the manganese. So when comparison you do, you take a ratio. When ratio you take, then gram and gram will get cancelled. How many times larger means carbon? They were considered carbon as a 12. Weight of carbon is 12. So what they were doing? Weight of carbon, mass of carbon, not weight of carbon, the mass of carbon for 1 mole is 12 gram. So 1 mole of carbon, 12 gram. What they were doing? That they were dividing that 12 by 12. So it is 1 part. So 12th part of carbon they were comparing with other element. So 12th part of carbon and manganese. So manganese was found to be the 55 times than 12th part of the carbon. So 55 remained the atomic weight. So it's a relation, no? 55 gram of the manganese and 1 upon 12th of carbon or 12th part of the carbon. So gram and gram got cancelled. Therefore, atomic weight has no unit. Is that point clear?
Yes, sir.
Yes,
sir.
Yes, sir.
Yes. But the term weight came for the weightage, for relation. It is not the term of mass and weight, literature term. So this weight concept is compared with what the other weight concept that is student physics is not different. Is the idea of weight clear? So weight means gram, weight means Newton dyne. It is not. It is related to what the relation, comparison. Is that term weight clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, still if you are there, they are not answering. See, repeatedly if I ask after few gap only, then also you have to what answer expected. Otherwise say don't want to answer there only. It's not to answer that also, but say that it is my expectation. So I will come to know you are not interested to answer. That recognition will be there properly. Okay, now the Avogadro's number of the species, maybe electron, maybe atoms, maybe ions or molecules, means 1 mole. That concept already you know. And mass of that in terms of gram comes equal to atomic weight, equal to molecular weight, depending on the species. Means if I take 55 gram of the manganese, then in that Avogadro's number of manganese will be there. Or if I take Avogadro's number of manganese, the weight will be 55 gram. When that weight, maybe atomic weight, equivalent weight, molecular weight, expressed in terms of gram means mole, means Avogadro's number. I repeat, and I want consent from you. Are you following or not? The conclusion is Avogadro's number of the species. 1 mole of species means weight, which was not with weight, which was not with the unit, atomic weight, molecular weight, equivalent weight, in terms of gram. 1 mole of the species is equal to weight in terms of the gram. Is that conclusion clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Only 7, 8 students have replied. Further 8 are there, they have not replied. Okay, still
No,
you are
sir.
not following. Who is saying no?
Amisha.
Sorry, I could not. Amisha. Okay, I repeat. 1 mole means Avogadro's number concept clear.
Yes, sir.
1 mole of species, maybe atom, maybe ion, maybe molecule, or maybe reacting things, weighs that weight in terms of gram. Means what? 1 mole of the hydrogen is equal to its atomic weight, but in terms of what? Gram. 1 gram. So this gram and mole are related. Molecular weight of water is 18. 1 mole of water is equal to 18 gram. The gram came because of mole. Otherwise, molecular weight of water 18 has no unit. Atomic weight of hydrogen 1 has no unit. But when we consider 1 mole, then the gram came. So Amisha, what I'm talking, mole means here gram will come. Expression in gram means mole. Are you getting this point?
Yes, sir.
Yes. So I hope the other students also clear. But expression in gram is every expression? No. Expression of 1 mole. Weight of 1 mole. Then that is what the atomic weight, molecular weight as such. Okay. Now our point of interest was water molecule, H2O. 1 mole of water molecule means how much mass? Or in general way you can consider how much weight. General sense point of view.
18 gram.
18 gram.
18 gram.
Absolutely, you are right now. If you would have said 18, then it's a mistake. 18 is the molecular weight. But here mole said no, then express in terms of gram. That was the side, that's presentation there, no? Here, see, mass of 1 mole of water means there should be what? 18. So mass of element, see, 1 mole of element in 1 mole of compound. So 1 mole of water, in that how many hydrogen will be there? Yes, in 1 mole of water, how many hydrogens? Many number I want only. 1 mole of water molecules, how many hydrogens?
2.
2 gram.
2.
Yes.
2 gram.
No, don't say gram. I said number, mole. 1 mole of water means 2 moles of hydrogen. 2 moles of hydrogen. 1 mole of hydrogen means, yes, 1 mole of hydrogen means is equal to
1 gram.
mole came there. What will be there?
1 gram.
Right, 1
Gram.
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 2 mole is equal to 2 gram. Mole comes, then it will be in terms of gram. If it's atom, then atomic weight. Molecule, then molecular weight. If equivalent, then equivalence of reagent, reacting species you have to consider. So mass of element, so in 1 mole, so 2 gram into 100 divided by mass of 1 mole of compounds of water. You write there the 18. Okay, your next lecture may be there. Let me stop. But considerable work I had given to you. What is the work? You write down as a homework now today for today's lecture. You write down those formulae. 4 formulae are there about which I ask you to work. You write only those formulas and the terms involved in that. In those formulae is the assignment today. I repeat. What's the today's assignment? During lecture, I ask to work for 4 formulae understanding. To understand 4 formulae, you have to write those 4 formulae and their terms, explanation of the terms. Heading will be there. Relation among what? Formula and the terms involved in that. That is a work given to you. I will give you the study material. Means notes are there. PDF file I am providing. But you have to prepare the notes of that. Only relationship between the various terms. Is that homework clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
8 or 9 students are there. They are talking, but still many are there. Shruti, you are not discussed and you are not talk. Okay, many
Sir?
others are there. Yes. Have you answered?
No, Sam Poonam. She's
Yes,
suffering network problem.
Okay, network problem is there. But here name I am finding she is online. Okay,
And
therefore I am providing the recorded lecture. But again, students, humbly I request you, be clear cut, be honest. For example, yesterday I committed a horrible mistake. Mistake in the sense I was not habituated for that the whiteboard. I was not knowing these terms. But even though I tried that, it was mistake. I agree. But openly I ready to accept that. So have that openness. I keep openness from my side. I want from your side also equal response. Is my expectation wrong?
No, sir.
no.
No, sir.
No, sir.
No, sir.
Okay. So be honest, be clear cut. Wherever your problem, I am there. If you remember at SY, the same thing happened. Related to SY, I found this year you are talkative, you are enthusiastic, you are learning. If you are showing that you are learningness, I am there for you. But if you are showing you are running away, then I will so study material will get. Lectures will be there. But interaction, how I am going to the level till you understand that maybe not possible, I will go with my level of the teaching. But that is not a fair way. I will not be happy with that. So I request and I suggest be interactive. Okay, fine. Too much time I had taken. I stop the discussion and I declare here today's lecture is over. I'm going to stop the recording also. Yes, students, quit now.